little closer. How's that? My name's Dave Sossen. I am an investor in and an advisor to Coventry Associates. The company was founded by Craig Gardner, who's an MIT alum. He's also the inventor of the technology you're about to see. We're both MIT alums, and we met here at MIT through another one of the entrepreneurial ecosystem programs. So first question, really the only question you have to answer. What is the common element amongst these 5 pictures here? Wind turbines, an electric car, an electric truck, an airliner, and a CNC machine tool. So I'll answer it. The common element is high precision rolling element bearings. The rolling element bearings constitute a $30 billion with a B dollar global market. They're in everything that turns. And this is where we're focused. On the upper right, you see a typical ball bearing assembly. On the upper left is an exploded diagram. Where we work our magic is on the outer ring and the inner ring, and you're going to see in a second how that works. So here's a video. You see 3 tables stacked on top of each other with a grinding spindle on top and a grinding wheel attached to it. And in a second, the animation is going to start moving, and there it goes. We're dressing the wheel, putting a shape on it, and then we're grinding one of those rings that I alluded to a second ago. There it goes again, just repeating the cycle. Here it is in real life. It really works. All the flames and sparks are demonstrating we're really grinding metal away from the part. Normally, there's coolant, which suppresses all that, but we turned it off for dramatic effect. So that's that. Now, that was our launch product, but since then, we've developed a second product called the EPS multi-tool. EPS stands for Eccentric Positioning System. It's basically the same positioning system, but instead of doing a single operation, it can do an unlimited number of operations, limited only by the size of the machine you want to build and how big the building is you can build around it. Typically 3, 4, 5 operations on a typical system. Here you see it set up to do a rib spindle, an outer diameter spindle, and an inner diameter spindle, which are the 3 operations you typically have to do to make yourself a ball bearing. So now we get closer to the heart of it. What's it worth? So if you want to make ball bearings today, you need to go out and buy at least 3 big machine tools. There they are. They're typically each made by a different manufacturer. They don't integrate well together, and they each cost about $1 million a piece. And that's before installation and training and all the other stuff. Our machine does all 3 of those operations in one fully integrated, highly robotic system, and it costs about $1.5 million. So just capital expenditures alone, you're saving $1.5 million. So that's great. But what's the real impact? Well, we were asked to show what a customer situation looks like, and it looks like this. So this diagram is from a large manufacturer of ball bearings and other kinds of bearings. And I won't ask you to decipher all that. The point is, on the left side of that diagram, you see a schematic of one of their 500 production lines that they have globally. It's a very big company. On the right side is what that production line will look like, we hope, when they replace that stuff on the left with our technology on the right. Now, on the left, there are 11 machine tools, so round figures, $11 million of capital equipment, and 14 technicians to do the operations required. On the right, with the Coventry technology, it's reduced to 7 technicians and 5 machine tools. So 50% savings in labor and plus 50% in tools. What's it worth? Well, as I said, company is very large. They have hundreds of assembly lines globally. Typically in this industry, you turn over machine tools every 10 years. They wear out and either have to be replaced or rebuilt. We've done a projection with our customer that if over a 10-year period they replaced all their existing grinding technology with ours, they'd save $5 billion. That includes the labor savings and the CapEx. So we think it's worth doing. And I haven't touched on the performance advantages and the green advantages, which are significant. For lack of time, I've got 4 seconds. So we seek introductions to, obviously, precision rolling element bearing makers. Anybody, anywhere in the globe, we're happy to talk to. We are talking to several, but there's some, particularly in Asia, we can't get to. And machine tool makers who are both our competitors, but potentially also our partners, and in the longer term, even maybe an acquirer of the technology of the company. Thank you.